So a short video on percent yield. There was a request for that. And so I've got an equation here for potassium chloride KCl plus O2. And it's the balanced equation there in the purple, 2, 3, and 2. I've already calculated the molar mass of the KCl and the KClO3. See, that's an O3. And I've given you the starting amounts for the KCl and for the O2. I didn't calculate the molar mass of O2 because that's easy. It's 32 grams per mole. So this, it looks like it would start out as a limiting reactant problem. So we're going to divide each one of these by its molar mass. And then we'll divide each one of those by the coefficient. And let's see if I can calculate what that is real quickly. 37.3 divided by 74 point, oops. Start over. I got parentheses on there somehow. 37.3 divided by 74.55, and then dividing that by, holy moly, oh, that's it, and dividing that by 2, and I got 0.250, and the other one will be 20 divided by 32 divided by 3, and I got 0.208, which tells me, since the 208 is less than the 250, that O2 is my limiting reactant. So I will start with O2 and work this out and figure out how many grams of the KClO3 that we can make. So 20 grams, oops. Times 1 mole of O2 over 32.00 grams of O2. So the grams of O2 will cancel. Times 2 moles KClO3 for every 3 moles O2. So the moles of O2 cancel. Remember, we're putting all these labels on so the things will cancel. We know we're putting them in the right place. And then KClO3, 122.55 grams is 1 mole KClO3. And the moles of KClO3 cancel. So 20 divided by 32 times 2 divided by 3 times 122.55 equals, I got 51.0625 grams. I started with 3 digits. I should end with 3 digits. So that would be 51.1 grams KClO3. Okay. So, what do I want to point out here? Just a reminder, that's always 1, that's always 1. And these numbers are from the balanced equation. That's why we have the balanced equation. We use that in that mole ratio step 3 in the process. So that's 51.1 grams is the theoretical yield or theoretical mass. I think theoretical yield is the word they use. You always get the theoretical yield from stoichiometry. You always have to calculate the theoretical yield, unless they give it to you. I mean, and I'm not going to give that to you on the test. You're going to have to calculate that from the stoichiometry. Now, the problem will say something like, to the effect of, let's see, how can we write this? What color would we like to see? I'm thinking we haven't seen a dark green for a while. All right, so the problem might say something like this. Juanita did the actual experiment where she collected and dried and measured off 39.2 grams of KClO3. That means she did the experiment with the 20 grams of O2 and the 37.3 grams of KCl, and she was able to collect 39.2 grams. We'll assume there are no impurities in there, that she just got it all, and that's what she got. So this would be the actual mass. Actual mass comes from a doing of the chemicals, doing the chemistry in the lab. That's where you get the actual mass. So theoretical yield, or theoretical, I guess that's actual yield, not actual mass. Either way, you get the idea. So the actual yield comes from the procedure. The theoretical yield comes from doing the math. And then it's for the percent yield, it's actual divided by theoretical times 100%. You would hope that the actual would always be a smaller number than the theoretical. If it's not, you've done something wrong. You've either calculated your theoretical wrong, or you've measured your actual incorrectly with the scale, or you've got some junk in there that's not supposed to be in there. So actual should be smaller than theoretical. So we're going to take our 39.2, go back to the green, 39.2 divided by 51.1. This is grams, they're both grams. And it really, we have to have the grams are going to cancel, but they are both grams just for the sake of argument. So, oops, I lost my phone calculator there. So 39.2 divided by 51.1 times 100, and I get 76.712328767%. And again, we started with 3 digits here and 3 digits there. So we should end with 3 digits here, 76.1%. That's good enough for us. So that is how this is done. Pretty straightforward. You just have to do the stoichiometry to find the theoretical yield, read the problem for the actual yield, do that actual divided by theoretical times 100 to get the percent yield. And I hope that helps clarify anything that needed clarified. Good luck in your studies.